Alright, quick warm-up joke. Why did the quadratic go to therapy? Because it had too many unresolved issues until we set them equal to 0. Haha! If anything feels fast, you can pause to think. And when you're ready, let's turn to the next slide. X, the task is solve 2x squared minus 5x minus 3 equals 0. The numbers 2, -5, and -3 are the coefficients. So A equals 2, B equals -5, and C equals -3. The letter X is the unknown, and a root is any value that makes the left-hand side become 0. Keep these roles in mind, they steer every method we use. Let's turn to the next slide. Strategy time. The factor, if that's awkward, the quadratic formula always works. Completing the square reveals structure, and a quick graph is our final sense check. You can pause to think here and choose your favourite root. Next slide. Factoring first, test whether 2x skew S3 splits neatly. Try 2x plus 1 multiplied by x minus 3. Expand to check. 2x times x gives 2x squared, 2x times -3 gives -6x, plus 1 times x gives plus x, plus 1 times -3 gives -3. Combine the middle terms to get -5x, so it matches perfectly. Now set each factor to 0. From 2x plus 1 equals 0, we get x equals -1/2. And from x minus 3 equals 0, we get x equals 3. Feel free to pause and re-expand if you like, then on we go. Quadratic formula next as a verification. In words, x equals inus, the square root of b squared minus 4ac all over 2a. Substitute a equals 2, b equals -5, c equals -3. The discriminant is 25 plus 24, which is 49, whose square root is 7. So x equals 5 plus or minus 7 all over 4, giving 3, and -1/2. On the comparison table, referring to row 1, column 1, the method reads factoring. Row 1, columns 2 and 3 show 3 and -1/2. Referring to row 2 for the formula, the entries match exactly. Lovely agreement. Completing the square step by step. Referring to point number 1, begin with t2x minus 3 equals 0. Referring to point number 2, divide through by 2 to get x squared minus 5 halves, x minus 3 halves equals 0. Referring to point number 3, move the constant to the right. X squared minus 5 halves, x equals 3 halves. Referring to point number 4, add the square of 5 quarters to both sides. That is 25/16. The right side becomes 3 halves plus 25/16, which totals 49/16. Referring to point number 5, the left is a perfect square, x minus 5 quarters, all squared equals 49/16. Referring to point number 6, take square roots. X minus 5 quarters equals plus or minus 7 quarters, so x equals 5 plus or minus 7 all over 4, which again yields 3 and -1/2. 3 paths, 1 destination. Confidence rising. Time for a visual sense check. Look at the parabola for y equals 2x squared minus 5x minus 3, the x-axis, at -1/2, 0, and 3, 0, matching our roots exactly. The vertex is marked. You can pause to think and see how the symmetry lines up with our algebra. Quick checks before we wrap. The discriminant is 49, greater than 0, so there are 2 real distinct roots. Usations, the sum should be -b over a, which is +5 over 2, and 3 plus -1/2 equals 5 halves. The product should be c over a, which is -3 over 2, and 3 times -1/2 equals -3 halves. Watch out for common slips, sign errors in the discriminant, forgetting to divide by 2a, and not expanding to verify your factorization. As a quick contrast, consider x squared plus 4x plus 5 equals 0. The discriminant is 16 minus 20, which is -4 roots. The formula gives -2 plus I and -2 minus I, a complex conjugate pair, handy to remember for when factoring fails. Wrap-up time. We identified the roles of A, B, C, and X. Solved the same quadratic by factoring by the formula and by completing the square. Confirmed on a graph. A remanent, sum, and product checks. Thanks for watching. Please like and subscribe, and see you next time. And now our chant to remember the flow. Factor, formula, complete the square. Check the graph. Solutions there. Sum and product, numbers pair. We solved it right with maths to spare.